Have you ever just stared into a campfire and really wondered what is actually going on in there? I mean, fire is everywhere in our lives, from a birthday candle to the engine in our car. But it's not magic, it's pure chemistry. So let's dive in and uncover the secret of fire.
All right, here's our game plan. First, we'll crack the code on what actually makes a flame. Then we'll get into choosing the right fuel. After that, we'll face the tough stuff, the problems that come from burning things. But don't worry, we'll then look at some cleaner, greener options before we wrap up with how all this science can help keep us safe.
So what is the secret of fire? It's a question humans have been asking for, well, forever. And believe it or not, the answer is actually pretty simple. It all comes down to a super fast chemical reaction that you and I see almost every single day.
Okay, let's get right into it. The first thing you need to know is that fire isn't really a thing. You can't hold it. It's a process, a very specific chemical event that needs three key ingredients to happen.
And that process has a name: combustion. At its heart, it's just something, a fuel, reacting really, really fast with oxygen to release a burst of energy that we see as heat and light. You know, think about a candle. The wax is the fuel, the oxygen is all around us in the air, and that beautiful flame is just the visible evidence of their rapid chemical dance.
This brings us to the golden rule, the absolute key to understanding fire, the fire triangle. It's so simple, but so powerful. You need all three sides for a fire to even exist: fuel, oxygen, and heat. If you take away just one of those sides, poof, the fire goes out. Every fire extinguisher in the world is designed around this one simple idea.
Now, when you think about that triangle, the one side we have the most control over is, of course, the fuel. And that's a huge deal because not all fuels are created equal. So what actually makes one fuel better than another?
Well, an ideal fuel kind of has a checklist. You want a ton of energy out of it, right? You also want it to burn cleanly without a bunch of smoke or gunk left over. Then there's the practical side. It has to be easy to store and move around. And of course, it needs to be affordable and easy to get your hands on. So that whole idea of high energy output has a proper scientific name. It's called calorific value. It sounds complicated, but it's not. It's just a way to measure how much heat you get when you burn exactly 1 kilogram of a fuel. The higher the calorific value, the more power you're getting. Simple as that. And this is where it gets really interesting. Just look at the massive difference in power. You've got wood down here, around 17,000. Then you jump way up to petrol, at 45,000. That's a big leap. But then, look at hydrogen. It's off the charts at 150,000. Its energy potential is just on a whole other level. And yeah, we're definitely going to come back to that.
But, and this is a big but, all of this incredible energy comes at a price. For centuries, we've basically been burning whatever we could find without really understanding the fallout. So, what are the hidden costs of our love affair with combustion?
It really all comes down to how well something burns. If you've got plenty of oxygen, you get what's called complete combustion. It's pretty clean, mostly just giving off carbon dioxide and water. But when you starve a fire of oxygen, you get incomplete combustion, and that's where the nasty stuff comes from: soot and something far, far more dangerous: carbon monoxide.
And let's be absolutely clear about this. Carbon monoxide is no joke. It's a silent killer. You can't see it, you can't smell it, but when you breathe it in, it literally stops your blood from being able to carry oxygen. This is exactly why good ventilation is non-negotiable anywhere that fuel is being burned. On top of CO, burning fossil fuels releases this whole cocktail of other harmful stuff. You've got CO2, which drives global warming. You have sulfur and nitrogen oxides, which cause acid rain. You have that deadly CO we just talked about. And you've got soot, which causes all sorts of breathing problems. Each one is its own unique threat to us and the planet.
Let's just zoom in on acid rain for a second. It's a pretty straightforward and devastating process. Those sulfur and nitrogen gases float up into the atmosphere, they mix with the water up there, and then they fall back down as, well, acid. And it damages pretty much everything it touches: forests, crops, historic stone buildings, and it can wipe out entire ecosystems in lakes and rivers.
Okay, so that's the problem. It sounds pretty grim, right? But what's the solution? The good news is science is already showing us a path forward, a way to get the energy we need without destroying our world to get it.
This table really lays it all out for us. Wood, you can see, is pretty low across the board and high in pollution. Petrol gives us great energy, but again, super high pollution. But then, look over at LPG and CNG.
We're talking very high energy, very high cleanliness, and much, much lower pollution. This is a huge step in the right direction.
And when we look ahead, the picture gets even better. CNG is already our cleanest burning fossil fuel. Then you have things like biogas, which is renewable because we can make it from organic waste. And then there's the holy grail, hydrogen. Remember its insane calorific value? Well, get this. When it burns, the only thing it produces is water. That makes it the ultimate clean fuel. The big challenge now is just figuring out how to make and store it cheaply and safely.
Okay, for our last section, let's bring all this science right back down to Earth, into our own homes. Because understanding combustion isn't just about big ideas like energy and the environment, it's about our own personal safety. Knowing how to control the flame can literally save your life. So let me ask you a very direct question. You see a fire. Your first instinct, your gut reaction, is to grab water. But when is that the absolute single worst thing you could possibly do? Okay, you need to remember this. Never, ever use water on an electrical fire. Water conducts electricity and you could get a fatal shock. And second, never throw it on an oil or grease fire, like a pan that's caught fire in the kitchen. The water will instantly sink, flash boil into steam, and cause a massive fireball that spreads burning oil everywhere. For those fires, you have to cut off the oxygen by smothering them or using the right kind of extinguisher.
And that really gets to the heart of it all, doesn't it? The science of fire has given us unimaginable power. It warms our homes, it cooks our food, it powers our entire civilization. But as we've seen today, how we choose to make that fire, what fuel we put on the triangle, has massive consequences. It's a choice that directly impacts our own health, for sure, but it also decides the future of our one and only planet.